What's good, my fellow GeoGeeks and MetaMappers? Spatial Ninja here, bringing you This Week in MetaMapping. And this week, we've got a variety of different articles that'll cover everything from AI and digital twins to some new updates inside of ArcGIS. We'll also cover the differences between ArcGIS Enterprise and ArcGIS Online, so be sure to stick around for that. And as always, we will end today's episode with our MappyMeme of the week. So before we jump into the articles today, make sure you guys follow and subscribe to our YouTube channel, MetaMapping. We've got a whole bunch of different videos that we're constantly posting, shorts. We've got tips and tricks in ArcGIS, as well as This Week in MetaMapping, where we provide you all the latest and greatest news in the GIS and geospatial world. We're almost to our 50 subscribers here. Again, once we hit 50 subscribers, we'll be doing a giveaway. So be sure to share our channel with your friends and subscribe if you haven't already. But let's jump into our articles this week. First, starting here with an article from GeoWeek News. Maxar and Esri expand partnership, adding precision 3D in the living atlas of the world. So towards the end of June, Earth Intelligence and Space Infrastructure Company, Maxar Technologies, announced an expansion in their partnership with GIS leader Esri. Under this expanded partnership, Maxar makes its precision 3D data available for viewing in Esri's ArcGIS Online Living Atlas of the World. So per the announcement, users will be able to view Maxar's precision 3D digital surface model, digital terrain model, buildings, and vegetation vector data integrated into ArcGIS Online. So this is pretty cool here. Maxar is providing a variety of data sets to users of ArcGIS's Living Atlas. So utilizing satellite imagery from Maxar's fleet to create models at 50 centimeter resolution and an absolute accuracy of 3 meters. So pretty precise 3D data products here that will be available. Precision 3D offers digital surface models, terrain models, and vectors mentioned above, as well as point clouds and true ortho from their satellite imagery. So Maxar collects a variety of different imagery products using their satellites and then churns out these different 3D products. So ArcGIS's Living Atlas is Esri's library of geographic information that includes maps, apps, and data layers available to ArcGIS users. So once again, this precision 3D data will be made available in the Living Atlas collection. So as we move to more of a digital twin environment, users will be able to immerse themselves in a digital twin that unifies the physical and virtual worlds for better decision making. So if you're a user of ArcGIS and you're leveraging the Living Atlas for content, be sure to check out this new Maxar set of data. Next article from GeoWeek News, exploring the possibilities of geospatial AI and image recognition. I think overall, I've seen a lot of folks start to leverage some of these deep learning processes and aerial imagery to do image detection. So let's see what this article has to say about that. AI image recognition has emerged as a powerful tool with the potential to revolutionize how we extract, analyze, and interpret geospatial data. With the ability to automatically identify and classify objects and features in satellite imagery and LiDAR data, AI image recognition holds promise for applications in urban planning, environmental monitoring, disaster management, and more. Goes on to say that there are some challenges, although these capabilities are impressive. So continuing on here in the article, image recognition, when combined with geospatial data, GIS, and LiDAR, offers a powerful tool set for understanding and analyzing the Earth's surface. One prominent application is the extraction of geospatial information from satellite or aerial imagery. Again, I think this is probably the most common machine learning or AI process that I've seen today for GIS, which is doing that object detection inside of aerial or satellite imagery. And by analyzing these images, AI algorithms can automatically identify and classify various objects and features on the Earth's surface, such as building, roads, vegetations, bodies of water, and land cover types. Yeah, so you're training a data set to understand what a roof looks like, and then you're running that model against satellite imagery to detect all roofs within inside of that imagery. Image recognition with geospatial data can aid in change detection and monitoring over time. By comparing images or scans taken at different times, AI algorithms can identify and quantify changes in land use, vegetation cover, and urban development. So this is a good use case here, looking at change detection. Comparing aerial imagery from the past with aerial imagery today or satellite imagery, and then automatically detecting where vegetation is either increasing or decreasing, or where you have those changes in those images. So here they start to talk about some of the challenges. So despite significant advancements, AI image recognition and classification still face several limitations in their current abilities. Firstly, the accuracy of these algorithms heavily depends on the quality and diversity of the training data. Insufficient or biased data sets can lead to inaccurate classifications and limited generalization to new environments. Yeah, so, if you've only labeled 3 household roofs, you really don't have a good sample size to be able to detect all different types of household roofs. So as we create better and more labels and training data sets, the machine learning models will definitely become better, but you can have some bias based off of lack of training data or lack of labels inside your training data. Additionally, the interoperability of AI image recognition systems is limited, making it difficult to understand the reasoning behind their decisions, leading to concerns about transparency and trustworthiness. So how was that model created? Who created it? Is there any bias that somebody either knowingly or unknowingly put into that model? And until there is more interoperability or transparency, this comment here or challenge is all about potentially having that misleading data or not having trust within inside of that machine learning model, because not knowing how it was trained and the lack of transparency there. But this is still a very interesting use case in the AI space. Again, it'll be interesting to see how this all advances, and as more and more of these different machine learning AI image recognition models come out. Our next article from Where Next, working through the noise at a cost to productivity. So essentially, this article here talks about new research on traffic noise that shows that even at low levels, it can hamper business productivity, and it's another data point to executives might consider when analyzing the best places to do business. So a study out of Sweden's Chalmers University of Technology showed that even a modest level of traffic noise, softer than the hum of most household refrigerators, can distract employees from their work. Interesting study here. So these findings come as Fortune 500 businesses in big cities are, as the saying goes, working on their relationship. The pandemic drove some of their professionals to smaller cities and others to swear off commuting altogether. In many cases, that has left executives with excess work spaces and thorny questions about the future in big cities. I personally, work for Esri. Esri is located in a small city of Redlands. We don't really have too much surrounding traffic. But with that being said, we do have a light rail system that goes right by the office, and you do hear it from time to time, and it can be distracting, but I could not imagine living in and working in a downtown major metropolitan city and all of the honking and car noises. So interesting as companies are swaying their employees back into the workplace, how they're starting to factor in the noise in these cities. Because as this study says, there is a direct correlation between the background noise and the productivity of workers. So the rest of this article goes on to talk about how GIS and spatial analysis is helping to understand noise and noise pollution, and so on. So last bit here, the article: executives intend on creating productive workspaces in a new office or lab facility might analyze U.S. Department of Transportation's data on noise levels. So this particular data set could be useful, but again, GIS could be also just used inherently with spatial analysis to look at noise levels surrounding buildings. So I thought this article was pretty interesting here. Good use case for GIS, but also just knowing how we're starting to come back out of COVID and return to the workplace. Just another point here where management teams, executive teams have to factor in, is it more productive for their workers to stay at home and work from home or come into the office? And if they do come into the office, what could be affecting productivity? One of those being surrounding noise or traffic noise. Okay, so next article here: drone monitoring tackles growing algae threat to California's famous Lake Tahoe. So the Tahoe Environmental Research Center uses GIS and drones to monitor the environmental health and water quality at its famously clear lake. So pretty interesting article. More or less, this article goes into how this organization is using drones and drone images to look at algae growth from above, and then from those images do calculations on how large that algae growth is and whether it's expanding, and how they are leveraging this newer technology to help prevent algae growth and detect algae growth with these newer drones. So to process and aggregate drone images, this gentleman, Barry, uses the cloud-based drone mapping software SiteScan for ArcGIS. After he completes each flight, he uploads images to the cloud while he's driving to the next site, and by lunchtime, photos are ready to look at and share with the rest of the group. So collecting these drone images, streaming them to the cloud, post-processing them, and then running analysis so that, again, they can look at the algae growth within Lake Tahoe. I like all articles that have to do with digital twins, AI, and drones. I think it's the future of GIS, and a very interesting use case here of monitoring algae growth from above. All right, so just a couple more articles, and we're going to start getting into some of the ArcGIS related news here specifically. And this article or blog from Arc News is all about the differences between ArcGIS Online and ArcGIS Enterprise. So I know when talking with ArcGIS users and they're trying to deploy WebGIS, there's always questions about whether or not to leverage ArcGIS Online, which is a SaaS offering, or ArcGIS Enterprise, which is a software deployed on servers. So this is a good article that kind of goes into detail on both offerings. So it says here, both products allow users to create, share, and use maps, apps, and scenes, layers, analytics, and data, i.e. web GIS. They also power Esri apps, enabling a range of geospatial workflows from mobile to app development and supporting the developer environment. But they're different products and different needs. So most critically, ArcGIS Online is a software as a service, as I mentioned, a cloud offering, whereas ArcGIS Enterprise is software you deploy in your own environment on your own bare metal servers or in your own cloud environment. Specifically with ArcGIS Online, users can access ArcGIS Online wherever there is an internet connection. This makes ArcGIS Online easy to set up and use, but it can't be customized and controlled the way ArcGIS Enterprise can, right? ArcGIS Online, it's a turnkey solution. It's a subscription model. It's already set up. You just log in and you've got access to all the bells and whistles. But ArcGIS Enterprise is software. It's installed on infrastructure that you and the organization manages. This gives organizations full control over their system, administration, security, customization, and integration. Right? You have to manage upgrade life cycles. You have to manage the back-end hardware, but you have more control over all of that because it is software. I'll share this article out, so be sure to track our Twitter. But this table kind of goes through some specifics on online versus enterprise. Then it goes into different deployment and maintenance options. Again, online is already set up and running and gets several updates per year versus enterprise. You have to architect and deploy it and decide when you perform your upgrades. Another major difference here is around the data storage options. So ArcGIS Online, users typically store and use data within the software as a service. So you publish, you host your data up in the cloud. Versus Enterprise, you get to choose whether you store your data. So you can host data inside of ArcGIS's data store, or you can deploy your own enterprise database servers and you can store your data there. So more control over where and how data is managed. Security requirements come into play when choosing online or enterprise. So online is a secure SaaS product with security strategy that's based on industry standards. It's also compliant with a set of security standards. But if you have more specific security needs, like you need an environment behind a firewall, then this is where ArcGIS Enterprise can come into play. Then lastly here, it talks about how to use online and enterprise together. I think this is a very common pattern that we see where you're using enterprise, but you also are using online to leverage some of the content and base maps, as well as be able to share content publicly or more easily get data and information out into the field. And you may set up collaborations between your enterprise and online accounts. So again, I'll be sure to share this article out, but if you are considering enterprise or online, this is a good one to reference and look at the differences here. Lastly, from the ArcGIS blog, new binning data in Map Viewer. So did you know that you can aggregate your data into map bins inside of the Map Viewer? So this is a newer capability, and binning in the Map Viewer can show the aggregated data with a defined bin boundary, which is different from other clustering styles available. So there still is, but previously a cluster option was available. Now we have binning as a kind of cluster style. A couple points to note here. You do not need to run analysis to create these bins, so it's doing this all on the fly. So how does it work? When you enable binning through the aggregation panel in the map viewer, the point features will be aggregated into predefined cells at a suggested size for the current map scale. So dynamically rebinning and changing the size as you pan and zoom. Then it goes on to show you how to enable binning in the map viewer. So we can see here, we've got a whole bunch of points. And in your properties panel, if you go to aggregation, you'll see this binning option now. And it's through this binning option, you can set all your different settings on bin sizes and so on and so on. Some of those settings include that bin size. So you can change, again, the size of your bin fields. So how do you want to base your bin size off of what particular fields? And then also with that, your bin label. So how do you want to label your bins, right? You can change the style of the labeling for all of your bins, as well as the bin pop-up. So when you select a particular bin, how do you want to show the summary results, or what information do you want to put inside of that pop-up? And then finally the style, right? So the symbology here, how you want to color code or use different counts and amounts techniques to visualize your different bins. So if you've not checked out binning inside of the new map viewer, be sure to take a look at that, especially since it's doing this all on the fly now. No need to do pre-aggregation against your data to get these different bins. All right, so this has been the articles this week in MetaMapping. We'll jump into our MappyMeme of the week. This MappyMeme was from a few weeks ago, but it was right during Barbenheimer and the release of the Barbie movie and Oppenheimer movie. I really liked this particular meme here. Error 99999. The famous error code that doesn't really help and provide any information about the error that you're receiving. So I enjoyed this MappyMeme here. So we'll like and reshare this post, I guess, this X post instead of this tweet. Lastly, be sure to check out our website, metaworldmaps.xyz. We've got a lot of information on here regarding our couple of NFT projects, Project Meta Expedition and City Maps Collection. Again, what we're trying to do is kind of bridge that gap between the latest and greatest in GIS technology and the latest in Web 3 technology. That includes everything from decentralization to blockchain, to cryptocurrencies. So if you're interested in learning more about Web3 and NFTs, check out our website, and make sure you guys drop a comment below this video asking us for more Web3 content. But with that, thank you guys for watching this week in MetaMapping. And as always, stay mappy, my friends.